Today we're going to really quickly look at solving a system of equations using elimination. As it states in the title, solving by elimination means that we're going to end up eliminating one of the two variables. Let's get started. The first step is to align the variables in your problem. We have two different examples here. The first example here on the left, the variables are already in alignment. What this means is that all of our variables and constants line up vertically into columns. As you look, you can see that all of our x values are in a column, all of our y values are in a column, and all of our constant terms are in a column. You'll also notice that our equal signs are also in a column. Our goal is to make sure that everything stays in standard form, or ax plus by equals c, where our x term added to our y term is equal to our constant. For this problem on the right, however, you'll notice they're not in this format. The second line is perfectly fine because it's in x plus or minus y equals a constant. So that's all right. But we're going to have to modify this first line. So y equals negative 3x plus 5. In order to fix this, we'll have to move our x term to the left side. To do this, we'll add 3x to both sides. This results in 3x plus y equals 5. Now, we're in standard form, and we can build our system of equations using our original equation and this modified equation. These two together will form a correct system of equations once those variables are aligned. Step 2 is to make sure that one of the variables have the same coefficient in both equations. As a reminder, a coefficient is the number attached to a variable. In this case, our coefficients are 2 and 3. Interestingly enough, we don't care if they're positive or negative, only that the numbers are exactly the same. If we look at this example to the right, we'll notice that we have different numbers. A 2 and a 6 attached to our x, and a 1 and a 5 attached to y. So we'll need to fix that. When we try and think about how we can do this, we need to think about the distributive property. For years, we've been told that the distributive property allows us to do this. That, for example, 3 times x plus 1 is the same thing as 3x plus 3. This is important because it means that these are the same equation. If you were to look at this problem, 2x plus 1 equals 5, and then, for example, if you doubled each of those values and got 4x plus 2 equals 10, you could then go ahead and solve them. If we solve them, we'd subtract 1 from each side. 2x equals 4. Divide by 2, we get x equals 2. For this second equation, we'd subtract 2 from both sides, get 4x equals 8. Divide by 4, and discover that x is still equal to 2. As long as we are using a solid multiple, the value of the answers don't change. This means that we can come over to our system of equations here and multiply one of the equations by a number and not change the value of the answer. In this case, we're going to look at changing the y values to be the same number. So to do this, we have to determine what we have to multiply the top equation by. Since the bottom equation is a 5, and the top currently has a 1 as its coefficient, we know that what we're really going to do is multiply the entire top value times 5. This is going to give us a new system of equations, where our top line becomes 10x plus 5y equals 100, and our bottom line will stay the same because we haven't multiplied or changed it at all. So our new system of equations is 10x plus 5y equals 100, and 6x minus 5y equals 12. The next step is to combine those two equations using addition or subtraction to eliminate a variable. As we do this, let's look at what happens. We once again have our system, same as the last problem. Since we've made sure that the y variable has the same coefficient, that's the variable we'll eliminate. So we have a positive 5y and a negative 5y. We just have to decide if we need to add these two together or subtract them from each other to make a 0. Our goal is to get that 0 right there. Since positive 5 plus negative 5 equals 0, we know we're going to add them together. So let's do that. 10x plus 6x gives us 16x. 5y plus negative 5y gives us a 0. And 100 plus 12 gives us 112. We've now eliminated the y variable and resulted in just the equation 16x equals 112. Our next step is to solve for that variable. Since we've already broken down our equation into 16x equals 112, it's a simple matter to use inverse operations to solve. In this case, we'll divide each side by 16 and discover that x is equal to 7. That's it. That's all we have to do. To finish, we need to find out the value of y. We already know that x is equal to 7 from our last problem, so what we need to do is plug it in to one of these two equations. And it doesn't matter which one. All you really need to do is determine which one you feel is easier to solve. In this case, I think that this is going to be the easiest equation to solve. So 2x plus y equals 20. I'm going to plug in 7 for x and get 2 times 7 plus y equals 20. Continuing our math, we discover that 14 plus y is equal to 20. We'll subtract 14 from each side, and we'll discover that y is equal to 6. Now we've found a y value. So our final step is simply to list it as a solution. We know that x is 7, and we know that y is 6. Whenever we answer a system of equations, our solution should look like an x-y coordinate pair. So in this case, our final answer is 7, 6. Remember, what this really means is that 7 and 6 make both equations true. It's simply stating that if you were to graph these lines, one of your lines would pass through this point 76, as would the other. Remember, this intersection point is that solution. And that's how we use elimination to solve systems of equations. Next up, we'll look at using substitution.